Hi everyone, Chad here. Thanks for joining me. Here's how you do linear flow rate calculations. Before you can start, you'll need the column diameter to calculate the cross-sectional area of the column, which we could redefine as the volume of a single centimeter of height, or mils per centimeter. This is just the radius of the column in centimeters squared times pi. Notice that we don't need to know the volume of the entire column or its height. So to calculate the linear flow rate from a volumetric flow rate, we multiply mils per minute by 60, the number of minutes in an hour, and then divide by the cross-sectional area in mils per centimeter. This will give us units of centimeters per hour. So say for example, we're running a 2 mil per minute with an XK26 column. This column is 2.6 centimeters wide, or 5.3 mils per centimeter. We would multiply 2 mils per minute times 60, then divide by 5.3, and we would end up with a linear flow rate of 22.6 centimeters an hour. Of course, you can rearrange this equation to find what the volumetric flow rate for a given linear flow rate is. So let's say the manufacturer recommends 250 centimeters an hour for some kind of affinity resin, and we have a 1 centimeter column. This column will have a cross-sectional area of 0.785 mils per centimeter. So we multiply 250 by 0.785 and then divide by 60, which would give us 3.3 mils per minute. Resin manufacturers will usually recommend a linear flow rate, not a volumetric flow rate, because they don't know the column diameter that the customer will be using. It could be very narrow, or it could be a very wide process column. The linear flow rate is a useful tool in chromatography to express the retention time of a sample, regardless of the column's diameter or volume. It will take 2 hours to run a single column volume for a 60 centimeter SEC column at 30 centimeters an hour. If you're going to scale up a method to a larger column, we want to maintain the same retention time so that the target molecule has the same separation. So as we scale up or down, we use the same linear flow rate based on the cross-sectional area of the column. Here's an example. Let's say we're running that 1 centimeter wide affinity column at 250 centimeters an hour. Again, the cross-sectional area is 0.785 mils per centimeter, and we previously calculated the volumetric flow rate to be 3.3 mils per minute. For this example, let's say the column is 10 centimeters high, so that would mean the retention time would be about 2.4 minutes. Now, if we want to run a wider 2.6 centimeter wide column with a cross-sectional area of 5.3 mils per centimeter, we just plug in the numbers again to find that the volumetric flow rate for this scale would be 22.3 mils per minute. We can check our work and see that the retention time will still be at 2.4 minutes as well. Okay, I hope this helps. Thanks for watching, and good luck with your purifications.